Good morning, actually good evening everyone. Today I'll talk about the big cube theory. So this is something that you might have never heard of, but it's something that could be quite really useful unless you're not interested in solving cubes bigger than the 5 by 5, especially not if you're interested in solving bigger than the 3 by 3. So what this theory says is that if you know how to solve a 3 by 3, which is obviously mandatory, and if you know how to solve the 4 by 4 using 3 by 3 algs, as well as the 5 by 5 using your 4 by 4 knowledge, and being able to adapt some algs such as center building algs and edge pairing, as well as parities algs. If you know that, you will just need to know how. We'll just need to understand how centers are built and how edges are paired, as well as how parities occur, how using this, or for example this or this slice will change how the edges will look, and so how to adapt an alg to a much bigger cube. But so it's pretty much simple. It's not like a bunch load of things, theoretical things. It's just easy, and with that you can solve any sizes. So if you know you already can, you can skip this video, and if you don't know, I will go a bit more in depth. So of course this theory apply for every method, such as for the Yale, Stadler, Mayer, K4, Cage, Sandwich, and plenty others, column first, reduction of flow. You can of course use them on any size, but for some methods like Yale, naturally still K4, or the Hardwick method, and the Hoya, other things like method like those ones could be really hard to use on bigger cubes, as starting from the 3 by 6. So just make a quick example on how to choose well, your algs, for example, for the centers, because it's the first thing you usually solve unless you're a cage solver. So it's so if you take a look on the centers, you'll the screen and this area has been swapped. But let's see on the 5 by 5. It's the same thing, but if you do the 4 by 4 arc, it will solve the centers. But if you do that on the 5 by 5, you will solve the centers and mess the corners of the centers, mess up the edges of the centers, the T centers. I think it's called like that. So need to another arc that that of course work on the 4x4 regardless of the edges. So I'll also make a edge example. So so in this case, this two need to be swapped. Do this one go here, this one go here. So you'll generally do something like so, flipping it, then doing the slicing and the flipping arc, then undoing what you did. But if you do that on the 4x5, you won't end up with the same thing. Leaving you with the parallel parity. So I hope you understand it and that it will help you to choose the arcs for the 4x4 and also be aware of how the 4x4 arcs will affect the bigger cubes and how the fact that changing the slices will potentially change the edge how you want to affect. So that's all for the video. I hope you enjoyed. Thanks for watching. See you.